can't tell if this is working or not. Is this working or not? Is this working? I can't tell. Okay, I'm just going to assume that this is working. So what we want to do is I want to make a traffic, like a set of traffic lights. So you've got the red, amber and green, and we're going to start from scratch. So the first part is just to do, we just want to write some code, deploy it to our Arduino, and then have a light working, one light, which is our green light. So in the beginning, we're just going to write some code. So we use this green tick to verify, and straight away we're getting, there's some code missing, so we need a setup function and a loop function. So this area here, this output is helping us write our code. So what we're going to do is we're going to define a function called setup, and when I code in a way that I'll avoid errors and problems in the future. So I normally code in a way where I'll go void. We need a setup function, so set up, and then I'll do my brackets, and then I'll do my braces as well, and that should compile. So that's our setup done, and then we'll do the same for loop, void loop, brackets, and everything's good. So whenever I create a function, I don't just start coding, because what can happen is you might forget, like the void. So if we go train setup, and then we start coding. Let's just say that bracket isn't there. There'll be errors, and then it can be hard to debug. So we've got an error, train setup does not name a type, and then you'll be scratching your head thinking, oh, what's going on with that? So I always code where I'll do void, and then the name, bracket, braces, and then I'll run it and compile it before I write any code, and that just helps avoid bugs. Otherwise bugs can take ages to debug. Okay, so we've got our code running on our Arduino, so we do a verify, make sure that there's no errors, which there's not, and then we run it, and we see our lights light up, and that means that our code has been compiled and it's been installed on our Arduino and it's running. So for this project you'll need 2 ground cables and then 2 5-volt cables. I use red and black. It's fine, you can use whatever colours you want, but I use them. I've got other ones like yellow, green, all the rest of it. And then you'll need a LED and a resistor. So, and you need the resistor because the LED will burn out if you don't have it. So you can connect your LED directly without the resistor, but it'll shorten the lifetime of the LED. It'll be a lot brighter, but it will burn out over time. So next, and then we've got our breadboard. So this is what we're going to use to connect our components to the Arduino. So because you need like a little area to play where you can just plug things in, and because you don't want to directly put components directly on your chip. So we use this board, and if you think of this in terms of, this is made for a chip like this. I don't know if you can see it. If we took this chip and we placed it in this breadboard, some legs would be on the top part and some legs would be on the bottom part. And just think of these terminals in strips, so that they're like, all these strips across here are all connected, and across here they're all connected, and across here. Same with over here. All this strip here, this strip of 5 holes, they're all connected, and then the next strip is connected, and this area is separate from that area, and then all of these strips are separate. So whatever you plug in horizontally across will be separate, but anything you connect across like this part, they're all connected. And so the idea is, if you install a chip across this part, you can then wire up all your components to the pin. And normally you have, like, all the pins will be across here, and then you'll just put one component in for each pin. And you can do more, but generally there's just one thing connected, and this gives you an area to wire up everything. So we're going to have, the only thing we're going to have over here is our resistor and our LED. And what we're going to do is we're going to put our resistor across here, just because it's wide, and then we're going to do our LED across 2 of these strips, and then that'll be wired across to ground, and then 5 volts. So everything, components generally need a ground, and you connect it using a ground cable, and then so a component will need a ground connection as well as a 5 volt connection for it to work. It's like this resistor, one side will be ground and one side will be 5 volts. The same with this LED, one side will be 5 volts and the other side will be ground, and that will let the current flow through the circuit. So yeah, so what we'll do is, so for this we need to do a little bit of a design, like we need to think about what we're going to do. So we're going to have a light, and a light is an output. So we're going to use a pin as an output, And then we do want a pin as an input so that we can change the light. So what we're going to do is we're going to do a hash define pin, and then if we look at our pins, the first digital pin is pin 2. We're going to define pin in as pin 2, and then before we do anything we're going to build it. Oh, we haven't spelled define right. So we've written one line of code, and then whenever you write a line of code, it's good practice, especially in the beginning, to verify it using this tick icon, and then deploy it. And you don't have to do this, but this is what I do so that I know that every line of code compiles and runs. So that if I do have an error, I know the error is related to the line that I'm working on. So now we've defined our pin 1 as input pin 2, digital pin 2, and then we're going to do hash define pin out 3. So basically we're just naming the pins. So in our code, instead of writing 2 everywhere, we're going to use this pin in as a name. It's a macro. And then instead of using the number 3 throughout our code, we're going to use pin out, which is a better practice, because if you just see numbers throughout your code, like 2s and 3s everywhere, as your code gets bigger, it becomes more difficult to read and difficult to manage. So with our setup, we want to set up the actual pins on the Arduino. So we're going to have pin mode, pin in, and then our mode is going to be input semicolon, and that compiles and runs. We've got our light, so everything's working. So what we've done there is the pins, the Arduino doesn't know anything about what we want to do yet, and the pins aren't configured to do anything. So by this setup gets run once, and this function gives us a chance to set up our Arduino to make it ready for what we're doing. So pin mode, pin 1, which is pin 2, we're setting it as an input. So if we didn't do this, the pins wouldn't work, because the Arduino doesn't know until we specify what it's doing. And then if we go pin mode, pin out, output, and then we compile that and deploy, and we've got no errors, which is good. So setup gets run once. Every time we deploy the code, it gets run once, whereas loop will get run in a loop. It'll be so setup gives you a chance to have everything set up for your application, and then okay, so we've got our setup done, and now we want to write the logic So loop is just going to be running continuously. If we go if, so with the if statement, the way I code if statements is very much the same as when I do so if I do a function, I do the whole function I write it so that it'll compile straight away. And it's the same with if statements. I've got the same practice where I'll go if, and then brackets, and then brackets, and then I know it'll compile once I put the condition in the if statement. If digital read, so do the brackets there, and then pin in. So what this will do is this will continuously loop, and it will continually check. It'll do a digital read on pin in, and just remember digital read is for input pins. So we compile that and we run it. So now we have this bit of code running continuously where it's checking for the digital read on pin 1, and we need to put in what we're checking for, which is high. So when pin 2, which is our pin in, is high, we can do something. So what we're going to do now is we're going to wire up our LED. And with these pins, the long pin is the 5 volt. So it's across the breadboard, so the 2 pins have their own strip. And then we're going to put in our resistor. Hopefully you can see that. And if I put it in line, yeah, that's all in line. So that resistor is in line with the lead, and it's the long leg, the long leg. And now if we do our 5 volts, we can get our 5 volts across here. So now we've got 5 volts from the 5 volt pin across to the breadboard, and the 5 volts is in line with the leg of the resistor, which is then goes across to the LED. And now if we connect our leg, the other leg, across to ground, we get our green LED, which is awesome. So this isn't using any logic. This is just 5 volts across to the resistor, across to the LED, and then to ground. So it's not running any logic because we haven't wired up any of our pins, input or output pins. So now we want to we're going to leave ground, but we're going to take the 5 volts off, and we're going to connect the 5 volts to the second pin. So now we've got pin 2 connected directly to our LED, and we should be able to write some code to test that. So we're going to take away our if statement. We're going to run that. And we're now set up. We're going to go digital write pin out, comma low. So we compile it and run it. And now pin 2, pin 3 is out. Pin 3. Okay, pin 3 is out. So now I've connected pin 3 to our resistor and LED. We've set it to low, which is off. Now we're going to set it to high. Yay, it worked. Awesome. So now we've just tested that our pin 3 does work. So when it goes low or high, it will switch the LED off or on. So now the next part is we want to so what we're going to do is we're going to set it to low, and then we're going to do a check for high on our input pin. Okay, so let's just go through the logic. We've set up our pin in as pin 2, pin out as 3, and then we've configured our pin in as an input and pin out as an output, and then we're doing a digital write to pin out as low. So we're setting the LED off when it starts up. So on startup, the light is off. And then we're going to check for digital pin in. If it's high, if it ever turns high, we're going to do a digital write, pin out, comma high. And let's build that. If I can spell properly. And we're going to run that. Okay. So the reason why the light's on is because it's probably reading high. So let's just comment that out for now. And what we're going to do is we're going to have our input pin, and we're going to set it to ground, and then we're going to put in digital write. Build it. Okay, so we're running. So now we're running our logic. So it's constantly checking to see if our input pin is high, which it's not, and then it's going to set the LED. So right now it's not. This is working according to our logic. And what we're going to do now is we're going to put it on 5 volts. Awesome. So now we have, depending on whether we set the pin or not, I think the way it's working is you don't need the 5 volts. I think the moment you take this off, it'll think it's high, which is, I think that's the behavior of the pull-up, input pull-up, and it'll remember. So whether we change it from now on, it'll just stay high because we don't have any more logic. Our logic is when the input pin goes high, the light switches on. That's it. Okay, thanks for watching.